All right, let's look at the homework 7, problem number 15. All right, so we want to find the interval on which the graph is concave upward and also concave downward and inflection points. All right, so let's do that. All right, so since we need to discuss concavity, we have to take two derivatives. So first derivative would be f prime of x is equal to 28. It's just a constant multiple. Derivative of e to the x is e to the x. Right, then you have a negative, and derivative of e to the 2x is e to the 2x, then multiplied by derivative of 2x, which is going to be 2. So I'm going to put that. So that's the first derivative. Right, second derivative is f double prime of x is equal to, again, 28 e to the x. This guy doesn't change. But you have negative 2, but the derivative of e to the 2x is 2 e to the 2x. So it's going to be 4 e to the 2x. All right, so since there's a common factor, so I'm going to pull out, let's see, 4 is in common, and also e to the x is in common, right? So if you pull out 4 from 28, you have a 7 left over. So 4 times 7 is 28. And then you have a minus, right? 4 is pulled out. E to the x pulled out from e to the 2x, so you have another e to the x. All right? So let's set this guy equal to 0. All right, let's see. So 4 is never 0. E to the x is never 0. Only way we can get a 0 is that this guy is equal to 0. Right? So which means what? So this means that right, e to the x must be equal to 7. Right? Then we can just take the natural log of both sides. Then you can see that x is equal to natural log of 7. Right? So let's draw a number line here. So we have a number line. All right. Then we're going to put a tip marks for a natural log of 7. So you have a natural log of 7. Right? Then we're going to try anything smaller than natural log of 7, like 0 or something like that. If you put 0, you can see that 7 minus e to the 0, 7 minus 1, which is going to be positive. So we have a positive second derivative. So I'm going to put, so here's a second derivative. It's going to be positive here. All right. And if you plug in anything bigger than natural log of 7, like 10 or something like that, then you have a 7 minus e to the 10 is going to be negative. Everyone else is positive, so you have a negative here, right? Which tells us that the original function is going to be concave upward on this interval up to natural log of 7. And then after that, it's going to be concave downward because its second derivative is negative. All right, so let's type it in. So we want the interval where f is concave upward. So it's going to be negative infinity up to natural log of 7. All right, so let's check the answer. All right, we got that. All right, then we want, let's see, interval where f is concave downward. So it's going to be starting from natural log of 7 and then go to positive infinity. All right, so let's check the answer. All right, we got that. All right, then let's see, we're looking for where the inflection point. So you can see that the concavity changes at x equals natural log of 7. So we put natural log of 7 there. All right, let's check the answer there. All right, we got that. All right, that's it. I hope that this was clear.